All right, here are 3 different subatomic particles. There are particles that are a little bit smaller than these. They're charms and neutrinos and stuff like that. If you get into physics, they'll play with those. In here, we just deal with these 3 particles. We deal with the electron, the proton, and the neutron. So the electron symbol is an E with a subscript or superscript minus here that indicates its negative charge. It's found around the nucleus. It has a very low mass in relation to your protons and your neutrons. I will very often use this symbol when I'm writing, so start to get used to seeing that. You can write with it yourself. You're welcome to use that for the symbol. It's a recognized symbol across the chemistry world, so even if you take AP and you're doing the exam, you can also use it on there. Protons then are a plus superscript. They're found in the nucleus. They have a +1 charge. We give them a mass unit called 1 because this mass unit is so small, it's difficult to work with. And the neutrons, they're also found in the nucleus. They have no charge, and you're going to find out in a video coming up why that's the case. Their relative mass is 1 as well, and then here is their relative mass. Notice this mass is just slightly larger than this one, and we're going to, like I said, we're going to come back to that idea in the notes as we move through the next week or two. All right, so getting back to the atoms, they're surrounded by these electron levels. The electrons of the atom most of the space consists of these fast-moving electrons. They're found in levels, they're negatively charged, and they are neutral. The atoms are neutral because we're going to have, when we're dealing with an atom, our protons and electrons are equal. We'll have a situation where we don't have these equal coming up in a few chapters, but right now, if you know your number of protons, you're going to know your number of electrons. Nucleus then is going to be a positively charged nucleus. That's because it contains the protons that have the positive charge. The neutrons are in there, but they don't have a charge. This nucleus is high in mass, but very low in volume, just teeny tiny volume compared to the amount of mass it has, because most of the atom's mass is contained in that nucleus. Atoms then are held together by the negative charged electrons being attracted to the positive charged protons. The number of protons is equal to the atomic number. It's the whole number on the periodic table, and this never changes. If it changes, then you're dealing with a completely different atom. The number of electrons equals the number of protons in a neutral atom. So this is something like you might see on the periodic table. You have your boron. It has an atomic number of 5. This is the mass number, and we're going to talk about why that's not a whole number coming up here in a couple slides. So pause the video, see if you can figure out what element, atomic number, protons, and electrons are in each of these atoms. All right, this is what you should have found for your work. Isotopes then are a situation where we have a different number of protons than we have neutrons. So these two things vary. The number of protons is what determines the atom. So in an isotope, if it has a different mass number and it's the same atom, then it's the neutrons that have changed. So mass number is going to consist of your protons and your neutrons, and we express that at the end of the element. There's also a couple other ways to express it that you'll see coming up in another video or two. Carbon then is here. Most of the atoms are carbon 12. Some of them are carbon 14. And that's why carbon's number on the periodic table is 12.011, because we do have a few of these thrown in. It's based on abundance. So the weighted average on the periodic table is based on the abundance of those isotopes occurring in nature. So like I said, for carbon here, the one that you're going to have the most of is going to be carbon 12. You're going to have a few carbon 14s, and that's why this isn't just 12. It's 12 and a little bit more. The atomic mass number is 1/12 of the mass of an atomic 12 atom. We consider that to be the mass of a proton or a neutron. We don't count in electrons because they're too small. They just don't have enough mass to really count. So here's a hydrogen atom. This is what we're looking at. If we're dealing with hydrogen, hydrogen has one proton. We can tell that by its atomic number on the periodic table. All protons, all hydrogen atoms have one proton. If they had two protons, they wouldn't be hydrogen anymore, they'd be helium. And if you look at this mass number, that will tell you how many most hydrogens have for their mass, for their neutrons. And you would know that that's 0 because the mass number is 1. If we have 1 for the proton, that doesn't leave anything for the neutrons. So most of the isotopes of hydrogen are hydrogen 1. Next, I want to show you how to calculate the atomic mass based on abundance. So if you want to try to pause the video and figure out yourself, you're welcome to. Otherwise, get the video running and I'm going to click to the next slide and show you the math for this one. All right. So we had 127. We had 80% of that. So I took it out of decimal form or percent form and put it in a decimal form. I multiplied those two together and I ended up with 101.6. 126, I had 17% of that. And so I multiplied those together. I ended up with this value. Over here, 128, I had 3% of that. Now be careful on this because people oftentimes will want to put 0.3 here instead of 0.03. And the problem with that is that you're going to end up with 38.4 over here. And that's not the correct answer. So once you get all of these added up, then you're going to end up with adding them together, 126.86. Now, way to go, good double check of your work. Does this number end up between the highest and the lowest values that you have over here? If that's the case, then it's probably the right answer. If you ended up goofing this and put 30% in here instead of 3%, this number down here would have been 161 point something. And the problem with that is that doesn't come between these. The other thing about this number is it should be closer to the value that you have more of. So this is, we have the most 127. So this value should be closer to 127 than say 128 because we only had 3% of that. So those are good ways to kind of double check your work and make sure that you're getting these right.